How did Copernican scientists calculate without modern tools? Imagine trying to figure out the movements of planets hundreds of years ago without telescopes, computers, or even precise clocks. It sounds impossible, but early astronomers managed to do just that. They relied on simple tools, keen observation, and clever math. The key was careful naked eye observations of the sky, noting where planets and stars appeared at different times. They used devices like sundials to measure the sun's position and determine the length of days and seasons. These measurements helped them understand how the sun and earth moved through the sky. Another tool they used was the triquetrum, a device made of 3 hinged rods. It helped measure angles between celestial bodies and the zenith, or the point directly overhead. By measuring these angles, they could figure out where planets were in the sky at specific times. They also used armillary spheres and astrolabes, which are intricate models of the sky that helped measure the positions of stars and planets. These instruments required careful setup and repeated observations to reduce errors. Since they didn't have telescopes, they made their observations at key moments, like noon or during planetary conjunctions. They recorded the angles and positions, then used geometry and trigonometry to convert these into distances and orbital paths. For example, by measuring how Venus appeared from the Sun at its greatest elongation, they could estimate the size of Venus's orbit relative to Earth's. These measurements depended on geometric relationships in the heliocentric model, which placed the Sun at the center of the universe. They also used tables of sine and cosine values, which are mathematical tools that help with calculations involving angles. These tables, derived from earlier mathematicians, made it easier to perform the complex calculations by hand. Astronomers combined old records with their new measurements, refining their models over time. They used epicycles, small circles that planets moved along while orbiting in larger circles, to explain retrograde motion, which is when planets appear to move backward in the sky. All these efforts allowed Copernican scientists to develop a model of the solar system that was more accurate than previous ones. They managed to estimate planetary distances and motions without modern tools by blending careful observation, simple instruments, and geometric calculations. This approach was part of the broader European Renaissance, a time when scholars looked back to classical knowledge and improved upon it with new methods. Their work set the stage for future discoveries, especially once telescopes and more precise instruments came into use.